Hello students, welcome to 11th lecture of surface chemistry. In previous lecture we were discussing about the micelles and how it works. So as we discussed earlier, in soap molecules, generally we have sodium stearate molecules. When we dissolve it inside the water, it dissociates and produces stearate ions. In stearate ions or these type of ions, it contains two different parts. One part is known as water loving or solvent loving head, and second part is solvent repelling tail. That means lyophilic and lyophobic parts. So because of two different type of parts, one part feels attraction towards the water and second part or tail feels repulsion from the water. If you have lower concentration, then all of these ions will be placed on the surface. In that case, heads are in contact with the water and tails are away or outside the water. That's why they are not feeling repulsion from the water. But if we increase the concentration, all of the surface will be occupied after a certain point, and then all of the extra molecules, ions, have to enter inside the bulk. Now at that time, to overcome the repulsion from the tail side, it forms all of these ion forms a spherical ball like shape. In this ball like shape, heads are present at the surface and tails are present at the center. So that's why they will overcome the repulsion obtained from the water molecule, because they are present at the inside of the sphere, and this sphere is known as micelle. And this is a simple two-dimensional representation of missile formation. Okay, you have to imagine it in 3 dimension. Just assume that you have a rubber ball or a cushion ball, and we are poking pins in it, sharp pins with head. Okay, so heads are visible from the surface because all of the surface is covered with heads, and sharp points are pointing inwards the sphere or ball, and they are not visible from the surface. So this is a visual representation of three-dimensional missile. So as you can see, this is a head of missile which feels attraction towards the solvent, and this is the tail hydrocarbon part of missile which feels repulsion. So when all of these ions have to enter inside the solvent, to overcome the repulsion from the solvent side, these tail parts will try to move away from it, but they are inside the solvent. So what is the solution of it? So they will form this type of spherical ball like shape. So we removed some of the portion of the missile from this sphere so that we can see inside it. So as you can see, all of the tail parts are present inside, so they are not in contact with water or solvent, and the head parts are present around this sphere. That means all of the surface is covered with the head, water attracting heads, so they are in contact with water molecule. Okay, so all the attraction or repulsive forces are balanced. Okay, so this is the formation of three-dimensional missile. This is the actual representation. Now let us talk about the cleansing action of soap. That means how soap helps cleansing with the help of micelle formation. So as it has been mentioned earlier that micelle consists of hydrophobic hydrocarbon like central core. The cleansing action of soap is due to the fact that the soap molecules from the micelle around the oil droplet in such a way that hydrophobic part of the stearate ion is in the oil droplet, and the hydrophilic part projects out of the grease droplet like bristles. Figure 5.7 represents the same thing. So as we can see in these three separate figures, first figure represents oily or grease particle on the surface, okay, which we want to clean. So when we add soap or stearate ions with it, as we know, oil droplets are non-polar. So that means it will feel attraction towards the non-polar part of our stearate ion. As we know, our stearate ion consists of two different portions, lyo or hydro phobic tail and hydrophilic head, that means water attracting. So this head part is polar by nature and tail part is non-polar by nature, and oil or grease or dirt like particles are mostly non-polar. So that means oil particles will feel attraction towards the tail portion, which is non-polar. So that means non-polar oil droplets or dirt particles feels attraction towards the non-polar part of our spirit. And at the same time, polar head is also present. So this polar head will feel attraction towards the water molecule. That means polar part will feel attraction towards the polar molecules. And that's why non-polar tails or non-polar bristles will deep insert inside the oil or grease particles, as we can see in image B. Okay, and finally when we wash it with water, it will form these type of micelle formation. Okay, in this micelle, inside we have oil or grease droplet covered it with micelle formation, which we seen earlier in the previous three-dimensional image. Okay, and then all of the head will be attracted towards the water, and that's why we can wash out this oil or grease particle from the surface. Okay, so this is the mechanism of cleansing action of soap. Now our next point is the preparation of colloids. So as discussed earlier in type of colloids, we discussed two different types of colloids based on interaction between the phase and medium. So first part was lyophilic and second was lyophobic. In case of lyophilic, all you have to do is add phase and medium with each other and you will get your colloidal soles. Okay, it is easy as that. But in case of lyophobic, actually phase and medium molecules are repelling each other, so it is hard to mix them with each other easily. So because of that problem, we need some preparation methods, and this is exactly what we are going to discuss in this point: preparation of colloids. That means we are actually going to discuss lyophobic colloidal preparation. So in this case, first we are going to discuss chemical methods. So colloidal depressions can be prepared by the chemical reaction leading to formation of molecules by double decomposition, oxidation, reduction or hydrolysis. These are name of some separate reactions. These molecules then aggregate leading to the formation of sols, that means colloidal solution. So some reactions are mentioned here, so let us discuss them step by step. So our first reaction is double decomposition. So as the name suggests, we will carry out double decomposition reaction. That means we will decompose two different reactants in the same reaction. So as we can see, we have As2O3 molecules and H2S. So both of them will going to be decomposed. That means we will break the bond between As and O as well as H and S from H2S. So both of them will break their bonds and they will change their respective negative ions. So you will get ASS compound and HO compound, as you can see at the product side. Okay, so our product is As2S3 and H2O. So our colloidal sol will be As2S3 in first case. Now second reaction is oxidation reaction. That means we are going to carry out oxidation reaction. So as we can see, we have SO2 and H2S, and at the final reaction you will get S as a sol, that means sulfur sol or colloidal particles, and water molecule. Okay, so we have to concentrate on sulfur portion. So let us find our oxidation reaction in it. So what will be the oxidation state of sulfur in SO2? So obviously it will be +4. In case of H2S, sulfur is in -2 oxidation state. Finally, as a product we have sulfur atoms, or in atomic state, or we can say that it is a elemental state of sulfur, and in elemental state oxidation state will be 0. So from the plus 4 to 0 or from the minus 2 to 0, we have two different possibilities for sulfur. So let us try to find in which of these two you will get oxidation reaction. So as we know, in oxidation reaction, oxidation states increases. So here we have minus 2 oxidation state to 0 oxidation state. So it represents increment in oxidation states. Okay, so it follows oxidation reaction. Okay, so we can consider that we gain our sulfur sol from the H2S as a main product, as a main reactant. Next, third one is a reduction reaction. So as we can see, we have gold chloride with formaldehyde and water. In due to the reduction process, you will get gold sol. Okay, so all you have to concentrate on gold ions or molecules or particles. So as we can see, in this case, initial oxidation state of gold particle will be plus 3 because it is attached with 3 chlorides. And after the reaction we have gold atoms or metallic gold. That means oxidation state will be 0. So change in oxidation state is plus 3 to 0. That means it decreases. So because of decreased oxidation state, we can say that for gold it is reduction reaction. And the last reaction is hydrolysis reaction. That means fourth reaction of chemical type. So from the FeCl3 hydrolysis, that means reaction with water molecule. So you will get FeOH thrice. That means ferric hydroxide. And this ferric hydroxide will combine with other molecules of the same type, and eventually it will create an aggregate or a bunch of different molecules which lays in colloidal range, and you will get your colloidal particles. Now second method is electrical disintegration or Brady's arc method. In this process, it involves depression as well as condensation. That means first we are going to separate out the small tiny atoms from the metal, and then we are going to collect them together. So colloidal sol of metal such as gold, silver, platinum, etc. can be prepared by this method. In this method, electric arc is struck between the electrodes of the metal immersed in the depression medium, as we are going to see it in figure. So the intense heat produced vaporizes the metal, which then condenses to form particles of colloidal size. So what is going on here? So let us discuss it step by step with the image. So first of all, what is electrical arc? So in this case, suppose we have two different electrodes like this. One is a positive, second one is a negative, and both of these electrodes, that means they are actually metal rods, and these metal rods are connected with let us say extreme high voltage batteries. Okay, they are connected with extreme high voltage battery. But note here, these two electrodes are not in contact with each other. That means our circuit is not closed circuit, it is an open circuit. So in the usual conditions, no electrical flows will obtain because circuit is open. But because of extreme high voltage attached with these two electrodes, they will ionize air present around it. Okay, so that means we have some air molecules present around the each electrodes. So because of extreme high voltage, these electrodes will carry some good amount of electrons, and because of this good amount of electrons present on the tip or surface of this electrode, they will ionize the air molecules around it, and air molecules, because of ionization, will conduct the electricity. So that's how, with the help of air molecules, electrons will reach from the one end of the electrode to the second end of electrode, and you will get electrical flow obtained from the help of ionized air. Okay, so this is simple design of arc, and these are some visual representation of this type of arc. So as we can see, in this case we have two different electrodes and they are not in contact with each other. That's why they will ionize the air around it, and because of the ionization of air, it will behave as a conductor medium, and conduction, during this conduction you will see some light emitted from this. Okay, or you can say that it is a one type of spark. When we switch on or switch off some electrical devices, sometimes we see sparks. Okay, it is a same type of example. So this is one more example. Because these two electrodes are very close to each other, high voltage of electricity will ionize the air, and because of ionization of air, which you are seeing actually a glowing part between these two electrode is plasma, fourth state of matter. From solid, liquid and gas we have one more, plasma and Bose-Einstein condensate. You are actually looking at plasma. Okay, these are some natural occurring these type of situation, electrical arc type or plasma formation. Okay, in the poles of electricity. And this is a GIF or representation of electrical arc. We have two high voltage electrodes close to each other. Because of high voltage of electricity, air present between these two electrodes will be ionized, and it will create a plasma. Okay, so this is electrical arc, and during this electrical arc, extreme heat will be produced. Extreme heat within a fraction of a time will be produced. Okay, because of ionization of air, high amount of heat will be released, and this heat is sufficient that it will quickly evaporate metals if it is in contact with it. So in our practical, here we have a metal piece. Okay, that means our phase. So it is in contact with these two electrodes. Okay, so between these two electrode, a arc will be created. That means plasma will be created at the center of these two electrode, and we have placed our metal between these two electrodes. So that means when the arc is being produced, it will create extreme, or it will produce extreme amount of heat, and because of this extreme heat, our metal piece will be quickly disintegrate. That means it will follow depression. That means it will quickly vaporize instantly. All of these atoms will separate out. Okay, that means from the solid state to gaseous state conversion in a fraction of time. But all of this instrumentation is placed in an ice bath, as we can see here. That means temperature of this container will be very low, and the temperature between these two electrodes will be comparatively very high. So as soon as metal atoms evaporates, they will come in contact with cold environment, and again they will follow or undergo condensation. That means few nearby particles will combine with each other, and eventually they will create a colloidal particle. Okay, so that means eventually they will grow in size, and you will get a colloidal particle. So that means first we are going to obtain small tiny particles of the metal, and then we are collecting them together or aggregating them together to obtain particles which lays inside the colloidal range. Okay, so that's why it is mentioned this process involves depression as well as condensation. First, depression, that means we will break down the metals in small tiny particles, and then with the help of condensation we are gathering these small tiny particles to obtain colloidal particles. And the last process is peptization process. So peptization may be defined as process of converting precipitates into colloidal sol by shaking it with the dispersion medium in the presence of small amount of electrolytes. So first you have to obtain precipitates of our sol or phase. Then we will add it in the dispersion medium with some small amount of ions. Okay, so electrolyte, that means ions, and we will shake it. So when we shake it properly, you will get your colloidal sol. The electrolyte used for this purpose is called peptizing agent. This method is applied generally to convert freshly prepared precipitates into colloidal sol. Okay. Now keep in mind we have to maintain the amount of electrolyte added or peptizing agent added inside the solution. Otherwise, it will create unstable environment and your colloidal soul will precipitate again. During the peptidization, precipitates absorb one of the ion of the electrolyte on its surface. This causes the development of positive or negative charge on the precipitates, which ultimately break up into smaller particles of the size of colloid. You will learn about the phenomenon on the development of charge on the solenoidal particles and their dispersion in the section 5.4.6 under the heading charge on colloidal particle. Okay, so we are going to discuss this point again in detail in point 5.4.6.